Why is it that gasoline is so prevalently used to power things, and why is it so hard to replace the use of gasoline? Well, in a nutshell, it all comes down to one thing: energy density. And whether it's gasoline, kerosene, or diesel, etc., all of them are high in energy density, and all of them have a similar energy density since they are all chemically quite similar. Energy density, simply put, is the amount of energy stored per unit volume. So the higher the energy density, the more energy can be stored in the same amount of volume. It is for this very reason that gasoline and other liquid hydrocarbon fuels are used in applications, where it is necessary to have a large amount of portable power with as little weight as possible. Gasoline and other liquid hydrocarbons really are the apex of fuels when it comes to storing chemical energy. Note that here I am, specifically talking in terms of chemical energy, so for example, nuclear fuels like uranium knock fossil fuels out of the park by a long shot when it comes to energy density. However, in this video, we are only looking at energy from chemical reactions, not nuclear reactions. So it's clear by now that gasoline, diesel, etc. really are the densest and most economical way of storing chemical energy that's known today. And it's exactly for this reason that replacing these fuels is very difficult. I mean, if you think about it, cars, trucks, planes, ships, heavy machinery, farming equipment, construction machinery, the list goes on and on. It's all powered by these fuels, and as all of the above-mentioned things are very important in making our modern world go around, it creates a sort of dependency on these fuels. Now, of course, for many of these applications, we can replace the use of gasoline and other fuels, but the fact is that when doing so, the efficiency in terms of energy density will go down with it, demonstrating the main point of this video, which is that the kings of chemical energy density really are liquid hydrocarbons, because of megajoules per kilogram. For example, electric cars replace the use of fuels in cars, making them more ecological when driving since they don't produce greenhouse gases. But the downside is that the driving range goes down a lot. So the typical lithium-ion battery stores about 0.8 megajoules per kilogram. Now, when you compare that to the 46 megajoules per kilogram that, for example, gasoline has, it becomes clear that batteries have just a fraction of the energy density that gasoline has. The average electric car battery weighs around 500 kilograms, while an average fuel tank holds around 50 liters of fuel and weighs around 60 kilograms when full. That means that the electric car's battery weighs around 8 times as much and takes up a lot more space while still storing less energy than the gas tank, resulting in that the electric car gets a smaller driving range. Also, the electric car's battery still weighs the same 500 kilograms regardless of whether it's empty or full. For comparison, if the gasoline car were given 500 kilograms of fuel, an average car could easily drive for over 4,000 kilometers. There are also some applications where replacing these fuels with other means of chemical energy simply would not work, or it would be too inefficient or expensive. So clearly these fuels dominate in terms of energy density, but the obvious downside is that they produce greenhouse gases and pollutants when they are burned. In fact, around 75% of all greenhouse gases come from burning fossil fuels. Now this includes things like coal, peat, and natural gas, etc. But nevertheless, the share of greenhouse emissions from burning these liquid fuels is still a major contributor in global warming. And with global warming causing more and more problems each year, it's important to reduce the amount of greenhouse gas emissions. So even though gasoline, etc. are better fuels in terms of energy density, we really should try to reduce and replace the use of them in applications where it is possible, even with the inevitable loss of energy density that comes with it. Also, we can try to consume and use these fuels more optimally, which would result in less emissions. For example, while driving big trucks and cars with powerful engines is really fun and all, but for regular day-to-day commuting, they consume a lot more fuel than is necessary to get you from point A to point B. So all in all, liquid hydrocarbons really are the best fuels available in terms of chemical energy density. Now, engineers have always been very aware of this fact. I mean, If you look around, it's no wonder that you can see these fuels used nearly everywhere and in so many different applications. And for a very good reason, because it's the densest, safest, and most economical way of storing chemical energy. And that really is the main reason for why we are struggling to replace the use of these fuels, even though we are fully aware that we should be reducing the use of fossil fuels to slow down climate change.